Hey adapters, welcome back. As governments around the world call for decarbonizing transportation and power generation, hydrogen is the next zero emission fuel that can replace fossil fuels to power a wide range of vehicles and fuel power generators. Waste2H CEO Jean-Louis Kindler joins us to explain how renewable hydrogen is being produced by extracting hydrogen from waste using a new circular economy technology. Jean-Louis has actively been working and running divisions and companies with an environmentally clean and green focus since the 1990s. He has wide experience in transversal clean tech projects involving fuel cells, renewable energy, and waste treatment. Hi, Jean-Louis. Welcome to the show.
Hello, thank you, Doug.
Well, it's a treat to have you on, and we're going to talk about hydrogen. We're going to talk about waste, but let's just get started there. What is Waste2H? What is your company?
So Waste2H is it's a startup. I like to call Waste2H an old startup because the company itself has been created in 2019, but we are commercializing a solution that actually has about 20 years development history. So we're new on the block somehow, but we're not exactly like total rookies in the hydrogen business.
Okay, so let's talk about hydrogen. We're hearing a lot about hydrogen as a new wonder fuel. So why is this happening right now?
Well, I would first start by saying that it actually is not exactly a new wonder fuel because it has been around for quite some time. Thanks to hydrogen, we send people on the moon. Well, I think it's what's happening today is the the awareness and really the climate change being more and more visible. We see wildfires, we see extreme temperatures. We saw that last week in Canada, and I think the whole world is finally coming to understand that this is because greenhouse gas emissions that has been down for now about 2 centuries, and so hydrogen is the answer to that, just like renewable electricity is the answer to that, because it does not generate CO2, it does not generate greenhouse gases. And so potentially, it has all what is needed to literally replace crude oil as an energy source. And potentially, but we'll talk about that later, I think. Potentially, it also has, depending on how we extract this hydrogen, it also has it gives us opportunities to literally take some CO2 out of the atmosphere and send it back where it belongs underground.
Okay, so I guess that's the issue. Yes, hydrogen has been around a while, but the production of hydrogen, when you use hydrogen, that in itself, you always have to factor in the carbon footprint, and that's where you come in, right? Because we do want to sort of be neutral in the production of hydrogen if we're going to use it as a fuel, right?
Absolutely. Well, today, as we're speaking, there is still about 95% of the hydrogen that's produced in the world that comes from fossil origin. It comes from natural gas, methane, that is being, we call that reformed to produce hydrogen. And that hydrogen is used mostly for two main applications. The one is ammonia production. We all know about ammonia. This comes in a lot of in different industrial uses. And of course, the other application for hydrogen is in refineries to take out sulfur from crude oil. So today, hydrogen is fossil, and what we need to do is, because we see more and more applications and more uses for hydrogen as a fuel in fuel cell vehicles, fuel cell trucks, etc., etc. It's very, very important that we start producing hydrogen in a totally different manner. The one that seems to be most visible today is what is being called the green hydrogen, which is hydrogen produced out of electrolysis, powered by renewable electricity. And then this is where we come to play. Our solution has been developed specifically to extract the hydrogen from waste, and waste is a renewable source.
All right, to explain that, so that's the kind of key technology here is that we generate waste as a society, and I had mentioned the word circular earlier, and that factors into this. So it's basically you're mining waste in the production of the fuel. So how do you kind of do that? Where are you finding the waste, and how do you scale that up?
Oh, waste comes to us. Um, our primary market today is waste processing companies or waste handling companies. So the companies that manage the garbage trucks that go to your place, my place, the local restaurant, etc. And all this waste is gathered in transfer stations. It is slightly sorted, and then in most cases, it is sent to another transfer station, and eventually it ends up either in an incinerator or in a landfill. What we propose, what we offer, is a solution where our systems would be installed on that first transfer station. So where waste is actually delivered to well, not to us because we do not operate those systems, but to our clients. And then that waste is processed, hydrogen is extracted, and hydrogen can be used on site either for power generation to help increasing the renewable electricity on the grid, or hydrogen being extracted and used as a fuel in buses, trucks, vehicles, etc., etc.
Okay, so you're not there to be the sort of the big producer of the actual hydrogen fuel. Your technology is meant to be used by sort of middle people there. They're there at getting the waste, and they not, might produce it because they have a particular energy need, right? You're not going to be producing the hydrogen in mass.
Exactly, exactly. Our expertise is in building and delivering systems that process waste and extract hydrogen out of it. And so we are delivering those systems to the companies who will literally be processing waste and producing hydrogen.
Okay, so you'd mentioned that there was actually a longer history than just the history of your startup, but so where was this technology developed? I mean, what's sort of that story?
So, Waste to H is a partnership between a group of investors who are based out of Long Beach in California, a company called Clean Energy Enterprises. And our partner in Clean Energy Enterprises is a Japanese company called Japan Blue Energy. And Japan Blue Energy is the company that developed and improved, enhanced this technology since actually since the very early year 2000. I was living in Japan at that time. You may see in my background, I brought some little souvenirs from there, and I was working with JBEC at that time, and we built the first prototype, the first version of this technology between 2002 and 2005.
Can you define just I want to make sure that it's really crystal clear. So the circular economy though, and that's probably part of your marketing pitch, or do people your customers already kind of know that and that's why they want your product?
Well, our customers today have a big problem because, for example, if our customers are in California, they have California state telling them that within 10 years they should reduce the amount of waste they send to landfills by 75%.
Wow.
That's the landfill diversion mandate. Our customers have problems because the public does not really like incinerators. So they really all need to find an alternative way to process the waste that they are receiving every day. So the our solution, uh, I would say, naturally belongs to the circular economy, and I will give you an example. Our standard system is it's a machine. I guess I can call it that way. That sits on a 70 feet by 70 feet square, and that processes about 24 tons per day of waste. Out of these 24 tons, we extract. It sounds a little small, but we extract about 1.5 ton of hydrogen. Okay, um, 1.5 ton of hydrogen will fill approximately 300 passenger vehicle tanks.
Okay.
So we serve with 1.5 ton hydrogen. We basically have the equivalent of today's average gasoline stand in the US. 24 tons. of waste is generated by an average of population between 10,000 and 15,000 people. Okay, so assume the average car user goes to the pump about once every 10 days. It
Okay.
means that with this 1.5 ton per day, we can cover and fuel a total fleet of about 3,000 vehicles.
Wow.
Well, the good news is, uh, of course, we have children, we have grandmothers, we have etc. But the typically the 3,000 vehicles is what basically corresponds to a population of 10 to 15,000 people. So it really is circular economy because those vehicles, instead of being fueled by crude oil that would come from Saudi Arabia, from the back end, from Canada or elsewhere, it will literally coming from those people's trash. So it's very circular.
So do you find that, I mean, it seems like you're providing two very important services. Is, helping reduce waste that's out there, but then the other side is the production of the hydrogen, which can be this fuel. Do you find that your clients are actually more interested in the waste side of it, and oh, by the way, we're getting this fuel, or they're like, no, we need a steady source of hydrogen fuel and we're just reducing our waste? There's two markets there.
There's two markets, and it's interesting. It has slightly changed in the past 6 months, I would say. But when we started the company, it was very clear to us. We had a lot of inquiries coming from the US, where the main question and the main concern from our clients was, what am I going to do with this waste? I have a whole pile of waste that I cannot send to China any longer, that I cannot recycle because it's dirty, because it's not a pure stream. I don't know what to do with this waste. I need a solution. And in the meantime, we had inquiries coming from Europe, where European companies were telling us, "Oh, that's very interesting. You're producing hydrogen. We really want to produce renewable hydrogen." So there was those two different markets, which actually are just one. And to give you an idea, for example, we have recently signed a letter of intent with a company in the UK who is developing hydrogen filling stations. And what they want is to fuel those hydrogen filling stations with waste. And this is why we are targeting today installing about 40 of our systems in the UK to provide renewable hydrogen coming from the immediate neighborhood to those hydrogen filling stations.
Well, you're just in a good position to be. I'm sure your sales team. Well, I'm on the hydrogen fuel sales team. Oh, I'm in the waste reduction sales team. So that's a great position to be in. I've got a question that came in from the chat room. This is from Ken. Are regulations
Mhm.
like what is being proposed in California very important to driving adoption of your technology, or do you think adoption will happen even without these regulations that are being proposed?
Oh, um, adoption will come from I would say from a conjunction of different factors. Um, regulation will certainly help. Just like we see, for example, what's happening in Europe, and to a certain extent what's also happening here in the US, where we see at I would say midterm, we see internal combustion engine vehicles going out of market. But let's put it like this. For example, in California today, the thermochemical conversion process that is the basis of our technology is not recognized as a way to process waste. So there are definitely regulation changes that need to be done,
Hmm.
but well, there are new administrations, and certainly the whole hydrogen infrastructure, which is now actually being built. It's not something. It's really starting now. The This whole infrastructure building also well, it also comes with regulation changes, and it is being taken care of as we speak. Actually, we see different bills coming from either federal or state level that are making more and more space for hydrogen production technologies, including ours. It's not totally done, but it's definitely coming.
Okay, we have another question. It's from Mike. Is there any excess waste that is still left over from the conversion process? So you'd mentioned you get like 1.5 ton out of the 12 tons. Yeah, could you elaborate? I was curious myself.
Oh yes, well, obviously we are not magicians, so whatever comes into the system has to go out. Um, the So we produce, let's say we produce 50 kilograms of hydrogen out of 1 ton waste. Um, Most of the remain. So first, what really needs to be understood is that what we are processing is mostly renewable matter. Municipal solid waste. Once we have taken out metal, glass, ceramic, which we do not process in our solution, is roughly 80% what we call biogenic, so that it's renewable. And the remaining 20% would be plastics and other fossil origin elements. So um, we put that feedstock into our system. We extract almost all of the hydrogen that was into this feedstock, and the remaining fraction, well, it is carbon. There's a lot of carbon in feedstock. Typically, out of 1 ton, we would have about 600 kilograms. So 60% of the feedstock in mass is carbon. And that carbon, we actually use it as the energy source for our process.
Hmm.
We do not need any external fuel, any external energy source. We use the carbon that is contained in the feedstock to extract the hydrogen that is contained in that feedstock. And so um, I will also I will almost say a bad word here, but it is a fact that this carbon at some point has to go out, and yes, it comes out as a CO2. Um, the very important thing to keep in mind here is that this CO2, as I said earlier, is mostly renewable. It does not come from fossil origin. A small fraction of it comes from fossil origin, but most of it comes from a renewable source, and therefore it does not contribute increasing fossil CO2 into the atmosphere. That's the first very important factor. The second factor is this CO2 is concentrated into one single stream. And it means that when we connect, and we will be doing that, when we connect this CO2 outlet to a carbon sequestration solution, it means that our systems literally become carbon sinks. And this is what I was talking about in the very beginning of this of our conversation. Uh, Green hydrogen, the electrolytic hydrogen, is totally decarbonized. It is zero carbon. There is no carbon involved in the production of hydrogen when electrolysis is being used. There is carbon involved in our process, but this carbon, because it is present, we have here an opportunity to capture this carbon and sequester it, send it back underground where it belongs. And this is something that is really key. And this is something where we make the difference between again between green hydrogen, between electrolytic hydrogen.
Okay, so when you're able to do that, you're sequestering the carbon. You become part of even a bigger conversation around what's going on with all these international agreements with climate change. Is like we can actually capture the carbon. So you become a part of the bigger conversation. I think that's very exciting too. I have another question
Absolutely.
that I'm getting from Fahim. Are there any developments in the hydrogen storage technology? The weight and volume of hydrogen storage systems are typically high.
Well, yes, it is something that we are obviously very closely looking at. Uh, Ourselves as a company, we are not directly involved in the development of these technologies, but obviously, since we produce hydrogen, that hydrogen has to be stored and in a lot of cases moved to our site to where it will be used. We I personally have a lot of interest in a technology called metal hydrides, which are literally hydrogen sponges. It's some metal. Usually they come as powders, and they capture they capture hydrogen, just like carbon filters capture impurities in water, for example. And they allow storing really a lot of hydrogen in at almost atmospheric pressure. Whereas today it's a fact that the mainstream way to store hydrogen is compression or liquefaction, but liquefaction is for very large quantities. So I still think that compressed hydrogen, which now is the mainstream way to store and move hydrogen. All hydrogen fuel cell vehicles are using tanks that are at basically 700 bar pressure. But again, I'm very attentive to what's happening on the side of metal hydride and low pressure storage.
Okay, so we're getting at the end of the interview here, but I did wanted to talk about you have some new projects going on in Tokyo and Paris. Can you give us, I guess, a little preview of what's going on there?
Oh, absolutely. So Tokyo, we have just recently installed a system on a wastewater treatment plant. Well, I say we actually it's our partner JBEC because they are in Japan, so obviously they were the ones to handle this project. So there is a system now on a wastewater treatment plant that processes the sewage sludge, so it's the waste that comes out of water after it has been treated. We are building another system that we will deploy here in California around September, October. And we have recently been selected to be part of a very interesting consortium to literally build the hydrogen ecosystem, the hydrogen infrastructure on the Paris Charles de Gaulle Airport. So very soon there will be news about this.
Right.
We will start actively working on this project. In September.
Okay.
August is vacation time in France.
The whole month of August. I get it.
Yes.
Everyone's heading to the beach. Well, okay. I want to wrap up this conversation. It's been fascinating. If people want to learn more about what you're up to, or if even they're interested in maybe getting the technology themselves, what would you recommend that they kind of learn more about what you do?
I would invite everyone who's interested to visit our website at www.ways2h.com. That's WAYS, the number 2H, ways2h.com.
Okay, and we'll have that. There's a site for this page, and we'll have links to that too as people watch this. All right, Jean-Louis, this has been a pleasure. I actually hope we could have conducted this interview in Martinique, but maybe next time we'll do that on-site project with you. That would be kind of fun, although not take 2 days to get there. But thank you so much for what you're doing. I'm going to take you into just chatting if there's any additional questions, but I want to close out the episode. But Thanks again for coming on.
Thank you for having me here. Thank you.
All right, hold on one sec.